Welcome to the Hot Glass Show here at the Corning Museum of Glass Amphitheater. Tonight, we have a very special guest artist, Violette. Yeah, welcome her. That's great. Yep. Violette, very accomplished young woman. She's going to make a very interesting piece tonight with the team. That cactus that you see there, that's what is going to be created tonight. On a larger scale, yes, right. And so, to introduce the team, we have Mr. George Kennert, the young lady with the tool in her hand, Teresa Jurgensen. We have Heather Spivak. We have Frederick, but I always, Van Atta, right. We have Rasmus. And my name's Bob. I'm going to talk. We're going to try to keep you informed as to what's taking place, what's going on, okay? It's a nice group here, but we're also streaming live. We're all over the place, everywhere. And so with that, we want to welcome everybody who may be watching on the internet. Yeah, welcome. Welcome this evening. Jen, wasting no time here, she went to gather, that's the green glass, right? That's the green glass. Our studio, for those of you who wouldn't be familiar, here in the center is our 1,000-pound melt furnace, clear glass in our melt furnace. A reheat furnace there on the left, a second reheat furnace here on the right, but way over here in the corner, we have a special melt furnace that has green glass for Jen. And so that she's going to be able to accomplish this nice cactus. Because I think it's only one, right? Even though it may have those extra lobes on there, you still only call it cactus, not cacti. Right. But she's going to be able to use that green glass from the furnace to be able to make this all come together, make it happen. Now, some of you may wonder, how do you make the green glass? Is it different? All glass is not equal, right? So by adding different minerals and metal oxides, we get to create different colors in glass. Before you melt the raw material, you add these different materials, these different metals, and when it melts, it becomes that color. So iron is used, iron oxide, used to make green glass. And so one of our crew here at the Corning Museum was able to put together this special tank of green glass for Jen here tonight. Now, Jen hails from Vermont. She's here at the Corning Museum of Glass to instruct at the studio. The studio, our teaching facility, across the parking lot from where we're located. And she's been working this week with a group of students, showing different techniques, helping them develop their skills. Before we began, I had a little conversation with Jen. And so I asked her if there was anybody special to say hello to while we were streaming live right on the internet. And she said, yep, Nico and Bennett. So if you guys are watching, you can send us a little note, send us a little message telling us, hey, Mom, we got you on the internet. Yep, there we go. We'll get that first shout out taken care of. So, this is a nice, intimate group all day long. This arena for watching glass blowing, there have been lots and lots of people in all the seats, all up on the top and everything. So with this size of a group, I think I can handle questions. If you've got different kinds of questions while we're going through the process, feel free. Raise your hand. Ask me a question. I do my best to answer. So you see, Jen collected that green glass out of the furnace. This is solid now. There's no air bubble in there. But she's taking 2 cork paddles and squeezing the glass to create that nice disc, right? Flatten the 2 sides. That cork is nice and soft against the glass. If she were to use harder materials, when the glass is nice and hot and she can compress it like that, it would leave little marks. It would leave little impressions. But those corks, they're nice and soft, and they're nicely burnt in, so she's able to give it a nice squeeze and create that almost lollipop look to it, huh? Wouldn't you say? It looks kind of like a big lollipop on the end of that metal pole. Jack's, the glass blower's most versatile tool. She squeezes that constriction into the glass off the end of that blowpipe to help facilitate breaking the glass free a little bit later as she's ready to complete this part of the process. But we know that there's going to be lots of little detail that goes on with this. We can see from our sample here, Jen puts lots of little prickly spikes on the ends of those nice glass dollops there that she's got. She's using some special colored glass rod, and with that glass rod, she adds those with the torch, fuses them on immediately, and she's able to decorate each of those lobes. I don't know what that, I'm not much of a plant guy. I don't know what they call those lobes on the cactus. They must have a special name, right? It's not a branch, but it might be a branch. I could be a cactus, but I don't know much about them. So a few moments she gets to add some of those nice little details, and then the entire piece has to go into that furnace to get a little bit of a reheat. The glass is very susceptible to thermal shock. And so if the glass should get too cold too quickly, it'll crack and break. So Jen has a few moments. The glass is hot enough. She can do the decorating. And then Rasmus will take it and put it back in the furnace, give it an overall heat, establish that good safe temperature, which is about 900 Fahrenheit. Lots of Jen's work is very plant-like. She likes to find influence in plants for her work. She's got a nice garden, she told me, at home. Yep, she's got 3 acres, so she's got a real nice garden going. She's hoping that those 2 young fellas that I named earlier are making sure they take care of things while she's gone. And a nice detail shot by our AV crew, nicely done. You get to see how she applies each of those separately and quickly with that torch. That special oxygen-assisted torch. Nice hot flame there, about 3,000 degrees. Heats that little small amount of glass quickly, so she's able to place those on there. So a good chance to see how some of this is done. Jen created one of these a little bit earlier. We'll get to see her do this one, probably another one. Make these things happen. Put those together. And then I'm sure there's going to be a considerably larger piece that she'll work on as well. Now, one of the things about the glass is that as these pieces get larger, the radiant heat becomes more and more significant. So that nice fine work that she's doing a little bit later with a bigger piece, she's going to be even more quick to take care of those steps because that heat coming off the glass is going to get real intense. For anyone who may not know, there's glass made from sand, right? That's the main ingredient, all glass. All glass is made from sand. Add extra ingredients because not all glass is equal, right? There's soda lime glass that we use. There's that Pyrex glass that we're so familiar with. It's a different kind of glass. Sand is the main ingredient, but they use boron to make it have that characteristic that you can take it from the fridge and put it in the oven and take it from the oven and put it in the fridge. There's lead crystal. Lots of us like to look at the nice, shiny, sparkly lead crystal things that are made. Matter of fact, we've got a very excellent exhibition of lead crystal here at the museum set up in an effort to celebrate the 150th anniversary of Corning Glassworks being here in Corning, New York. There's another special kind of glass. When you melt just sand, it's called fused silica. What do we got?
I've got a good question for you.
Okay.
Why don't the tools create thermal shock when they come in contact with the glass?
Why don't the tools create thermal shock when they come in contact with the glass? Now, glass has some unusual properties. Part of it has to do with the thickness of the glass, okay? It's mass. And when you have a good amount of mass, the glass is going to retain its heat so that when you touch it with the metal tools, it's not going to be so significant. Now, making really fine goblets, things like that, a glass blower will ensure that the tools he's using, they have a little bit of heat in them already, okay? He knows that he doesn't want to touch them with something cold. If he's using a pair of jacks, he's going to make sure those jacks have a little bit of heat on them so that when he touches that material that's even hotter, he can stretch it, manipulate it, change it. That kind of thing. But it has to do with the heat and the mass of the glass. That's why those tools are used to allow us to make things happen and not just make the glass break. There are times we will make the glass break with those metal tools, and we'll use a cold tool for just that purpose, or even a little bit of water sometimes. Now, sometimes the metal tools will get so hot, they'll like to stick. They start to stick to the glass. It'll feel like resistance. It'll feel like almost like a break or something. And to be able to alleviate that, we'll use beeswax as a lubricant. All of those things really quite traditional. So more than 2,000 years. Here we go. There's that first lobe, nicely done. Put on this preheated metal paddle, and then it'll go into our garage. It'll go into a holding furnace. That holding furnace is going to be able to keep the glass at a hot, safe temperature. What would that temperature be? It's a little over 1,000 degrees in the garage. 1,025 degrees. A hot enough temperature so that the glass won't crack and break, but it's also not so hot that the glass would start to lose its shape, change its form. A good holding temperature in our garage. Jen collected another gather of glass. Whenever we take the glass out of the furnace, We call that making a gather. She went over to that furnace in the corner there where the green glass is, collected some more material. As she confers with George Kennert. There's going to be a true collaboration here a little bit later on in the project. Jen's going to make these different parts that she wants. And then George is going to create this nice big flower pot. Okay, and then with that flower pot, they'll be able to put those pieces together and create this cactus. Now we're talking. There's some glass. Another gather, back to the furnace, collect that material. Jen's using a pipe cooler. Oftentimes when we make these subsequent gathers, the pipe stays in there a little bit longer. It'll start to accumulate some heat. Oftentimes people will ask us, how come the pipes don't get hot? Well, a good glass blower knows that you want to heat the glass and not the pipe. But there's times when it's unavoidable when you're trying to make those big gathers. And so to help, we have a little pipe cooler. And that metal box there, it's full of water. And it allows us to use a little foot pump. The foot pump draws the water up into that trough, and it cools that pipe while we're working with it.
So why is the bench so far away from the furnace? Wouldn't you lose a lot of heat walking back?
Yeah, here's another question from the internet. Thank you, all you interneters. Is that the right term, interneters? The question was, why is the workbench so far from that reheat furnace? All right, a number of different reasons. Number one, we're not in a production mode. If you were in a production mode, you'd want to save every step that you could. And so you'd be much closer. Whoops. Woo. You'd be much closer. Number two, when you open the doors on that furnace, it gets hot. It gets hot. Glassblower likes to be comfortable just like anybody else when you're working, you know, as comfortable as possible. And so to remove it a little bit, it's still a short distance, not so bad. And of course, we have this rolling yoke. And as the parts get larger and larger, that rolling yoke will come further and further away from that furnace. A third reason is that being here in the amphitheater, we want you to be able to enjoy what's taking place. You want to be more than a witness, okay? You want to get a good look at what's happening. The AV guys have become really good at giving us some really nice pictures. But if that bench was right by the furnace, well, that AV guy would probably have to be wearing a bulletproof suit so he didn't get cooked. You know, he didn't get cooked while he was trying to get a picture. So it's not real far from the furnace. It's really a good, comfortable compromise so that we get to enjoy what's happening with the videos, and the glass blowers still have a good proximity to the furnace. But thanks for that question. So creating another one of these lobes, this time Jen decided to use these giant paddles. There we go, they're flatter. The first time she had those little ones, they're like 4 inches square. These are quite a bit larger, but same purpose. Same purpose, they work real nice. You give that a really nice squeeze, and it accomplishes that same task. Rasmus doing the heats. Jen gets to be here at the bench. She'll use those jacks, create that score line or jack line so that when she's ready, she can make that little tap to break that free. Yes, sir. Yeah, when we're rolling the glass on the table, that's the question. When we're rolling the glass on the table, is that more than just shaping the glass? It is more. It's not really for tempering, but it's to cool the glass as well. We're cooling and shaping the glass at the same time. Oftentimes, when we use this metal table, there will be a lot more decorative purpose in mind. And we can use the resistance from that table to cause the glass to twist or to fold, whatever it is what we're looking to achieve. But, yep, the metal table, our Marver by name, always a handy thing to have in every glass studio. Originally, we're talking even 4,000 years ago at the beginning of glass making, marble was used as a marver. You know, they didn't have metallurgy. They didn't figure that out yet, those kinds of things. And they used big slabs of marble. And through the years, although the material changed, they wanted to keep that vocabulary similar. And so it's become a marver by name. And what we do there, the verb is also to marver. Okay? Yep. Noun and verb, all the same. Yes, young lady. Yeah, why do we use the wooden paddles? You know, these paddles that Jen has been using, they're made of cork. They look like wood, but they're made of cork. Now, the wooden tools, they draw a lot less heat out of the glass. Often, when we're using a certain tool, it's because of how we want to draw the temperature out of the glass. Every time we touch the glass, we know that we're making it cooler than it would be if it was just cooling in the air. Wood tools take the heat out of the glass very slowly. Metal tools take the heat out of the glass even faster. And we also have some graphite tools. And graphite takes the heat out of the glass the fastest. Yep. But it's also soft against the surface of the glass. If we were to use metal tools, it would leave little marks, chill marks, or sometimes even little striations. But with the wooden tools and the cork, they're very soft against that surface, and they don't leave any marks. So we get lots more little dots added on there, lots more of those little spines. A question? Why do we need furnaces for glass? You know, to melt glass, we have to get to 2,100 degrees. Okay? We can only do that with a furnace. We haven't figured out how to get the sun to be that hot just yet. Okay? Yep, we want to use a furnace. That way we can control it. We keep it inside that big metal box. It's 2,000 degrees in there, but out here, it's pretty comfortable this evening.
All right, Bob, we've got a question from our boss, Carol.
Okay.
What is the largest piece of glass that Jenna's ever sculpted?
What is the largest piece of glass that Jenna's ever sculpted? You know what? When talking with Jenna earlier this evening as she was getting things prepared, I'm going to wait until she gets it. Yeah? Oh, she knows it.
It's probably about a 25-inch fern, similar to the ferns I've made here.
Ah, okay.
Yeah.
Okay. So Jen has been here before at the Hot Glass Show, and she's made some ferns. And she said the largest piece she's ever made is like a 25-inch fern. There we go. That's the answer. Very nice. That's a pretty good sized piece of glass. 25? And 45 bits. There we go. Yep, 45 little leaves on there to make. Yep. Yes, sir. Why does it crack? You know, I'm not exactly sure what you're asking me. Yes. Yeah, why does it do that? Okay. Okay, the question is, why does the glass crack if it gets too cold too quickly? Glass is not quite like metal, okay? When metal gets to a certain temperature, it goes from a solid to a liquid, okay? Glass doesn't do that. Glass is scientifically amorphous solid. That means that it doesn't really have a melting point. It just gets softer and softer and softer and softer. And glass doesn't have a matrix. It doesn't have a molecular matrix, okay? And so as it cools, it doesn't line up like metals do, okay? As they get to that certain temperature, it all lines up to their matrix, and then they're solid again. Well, glass doesn't have that matrix. And so if it cools too quickly, the interior is still hotter than the exterior. And I'm not talking about in a vessel form, but the thickness of the glass itself, okay? And the interior is going to be cooling at a different rate than the exterior. And that kind of thing causes stress, and that stress is what makes the glass crack. Good question. I'm not a scientist, but that's the best I understand it. So Jen adding more, as those lobes get larger, she's adding more and more of those little dots. I bet there's more than 45 on that thing. Hundreds. Yeah, going to be hundreds tonight. That's right. They're going to be hundreds. Yep. So Jen made these little glass rods. See, these are the rods that she's using. This is the color that she's using to create all those little spines, those little spikes. And this is colored glass. This is a beige color. It's called beige. We don't make the colored glass here. We don't do much at all with the raw material. Okay, we're able to buy this stuff from manufacturers who do a really good job and real consistent. And so it's much, much better for us as glass artists that we buy this and then we can spend our time creating this menagerie. Yep. All right, adding all those little parts, making lobe number 2. I see George is initiating a bubble here. George's got a blowpipe. The next one. I got you. Okay, George is getting things set up for the next lobe. I guess they're called lobes. Do you know what I mean?
I Googled it the other day, but I can't remember now.
Oh, okay. Well, good.
It wasn't a lobe. It's called a pad.
A pad. Clado. A clado. A pad.
Yeah, we Googled it.
Okay. Great. That's it. There we go. Learning a little bit about cactus tonight. Yes. Give me a moment. I'm going to come outside. We'll do that. There's a bit of noise. There's a bit of noise that takes place there at the studio. You know, the furnaces, they have their hum because there's the burners and things happening there. And being an old guy, the noise, you know, you hear the noise, but you can't hear people talk. It's, I mean, I don't know. It's part of getting old, I guess.
I'm wondering if the artist accepts commissions.
Right. Uh-huh. Yep. Yep. Our fan in the audience asked, does Jen accept commissions? I know she has galleries, and she puts her work in galleries, and it's available for sale, indeed. But does she accept commissions? I don't know. Yep. We'll give her a moment. She's conversing there with Rasmus. But, yep, we'll get a chance here. Looks like she's close to having that one complete. They'll probably bring that metal paddle back out when she's ready, and they'll tap that off. Yep. So, okay, they're going to do one more flash before that one's ready. She wants to make sure that she's got a nicely homogenized temperature okay, before she breaks that free so that when they put it into that garage, it'll sit there nicely. We don't have to worry about it. Yes? Yeah, the glass looks red, doesn't it? Orange, something. It doesn't look green, but it's green. Yeah. The heat, it's the amount of temperature, okay? Just like, we've been watching the last few weeks on TV, the volcano there in Hawaii, and that lava comes out, and it's all glowing and orange, but when it cools, it's black, okay? The same thing is taking place. The material is just so hot. It has that orange color, but because we know the material, because we know how that's all been put together, it'll be green. And it's a transparent green. You can see through it. Yep. Yes. How is the glass green? Is glass usually clear? A lot of people for lots and lots of years worked real hard to figure out how to make glass clear. Glass has got naturally a kind of a fuzziness to it, okay? But they figured out how to make it clear, and they called it crystal, okay? Now, to make it green, before they melt it, they add iron oxide. They add iron oxide to the glass when it's still sand, when it's still lime, okay, when it's still potash. They add iron oxide, and then they melt it. And because they put that in there, that different material in there, when it gets melted, boom, it's green. If they would do it with manganese, boom, it would be purple, okay? If they do it with cobalt, if they do it with copper, maybe you know copper, boom, it comes out that nice pale blue color, okay? So it's part of the mystery of glass, but people have been dealing with it for 4,000 years, and so they know that these things are going to happen when they do that. Yes? If they melt two different colors together, yeah, glass isn't like paint, and it's not like crayons, okay? So that when you mix them together, they don't just change into a different color. But depending on how you want to layer glass, you can layer the different colors, okay? And make different kinds of hues, a different color happen. But if you layered blue over red, you wouldn't necessarily get purple. Okay, you'd be better off trying to get manganese to add into that recipe to make purple glass. Okay? Yeah, it's not quite. It's not like paints. It's not like the color wheel, right? Yep. Oops. Okay, George is helping out here. Going to create this next. What was it called? A clado. A clado. Okay, I'll take your word for it. Yep, that's fine. So there we go. Got another one. Doing the squeeze with those cork paddles. So we get to do these great little occasions where we get a glass artist to come in and do a feature these different evenings. And it's always a treat to see how other folks like to work with the material, make it happen. Because we have these different ways of looking at the glass, and there's not necessarily just one way to make it happen. Jen, would you have a moment? A lady asked, do you accept commissions? Do you do commission work? There we go. She does some commission work. Yep. Uh-huh. Right. Okay. Yep. And I also know that she has a really nice feature in the recent Glass Art magazine. So if you see a Glass Art magazine, you probably get lots of her information along with a real nice feature article about her and her work and so forth and so on. Yep, Glass Art magazine. Another question. Okay.
Phil, why specifically do we use cork for the cork paddles? Why not like some other wood or something like
Yep. Why do we use cork for the cork paddles? Number one is they're soft. I mentioned that earlier. But even though they burn rather slowly, okay? That cork is really pretty dense and real soft. And a set of cork paddles can last a long, long time as long as you don't mistreat them. Now, there's another group of thought, and it has to do with how it smells. Some glass blowers really like the smell of burning cork, and some glass blowers hate the smell of burning cork. So that's another part of it. And it depends on what group you're in there. Yeah. You could use wood, but the wood would be a little bit stiffer. When they made those first couple of heats, you know, when it was still round, the glass was really hot. And if you squeezed it with the wood, you could very easily put little lines in it, little striations, and it would be tricky. If you used metal, you would definitely put striations in it. And if you used like the metal table and laid it down and then flipped it over and laid it down, you would get what we refer to as chill marks. The glass would get little shrivels in it, and then you'd have to reheat it really well to get that to be smooth again. And so Jen knows from her own experiences, hey, you take those cork paddles and you give it a couple of squeezes, hey, you know, let's move on. Yep. That works out real nice. Yeah, thanks to those internet folks. We like to answer folks' questions, so, yep, we're more than happy to do that. So applying more of those nice little spikes. That torch, about 3,000 degrees, a quick little heat, and it melts that really thin rod because it's so nice and thin. You know, it doesn't have a lot of mass. Quick temperature, boom, makes it nice and soft, makes that application, and then they're on there permanent. Okay, that's one of those features. Make sure that the glass is hot, and it's on there permanently. Working together. If I remember reading that article correctly, Jen began glass blowing here at the studio. She's taken classes there. Now she teaches classes there, but she's taken some classes there. Oh, yeah, okay. And then, yep. Okay. Okay. Ah, all right. So, graduate of Alfred University, not far from here. Yep. And a BFA from there. 27 years of experience. Yep. Jen Violette. Yep, I remember in the article, she's been to Pilchuck and to Haystack and Lino Tagliapietro, right, Dante Marioni, Billy Morris, Karen Willenbrink. Yep, that's a pretty good crew to be involved with. So I don't know if you noticed, but it looks to me like each of these lobes is getting a little bit bigger. Huh? Right. Getting a little bit bigger. She likes to feature fruits and vegetables in her work. Yeah, she does a lot of work with powders as well. Been seeing her work with the glass out of the furnace and these glass rods, but her very special work, she uses powders, glass powders, to be able to duplicate the real colors that she sees when she looks at the different plants, fruits, vegetables. Now, all of those different types of colorings, the powder, the rods, oftentimes we'll use frit here at the Hot Glass Show. It's all the same material, just ground into a finer kind of a powder, finer grit itself to be able to work with the glass. That powder, often like flour, needs a very special little booth, a powder booth, so that it draws, it has a vacuuming kind of a draw in it. It takes care of any loose dust that might get away. A big part of the studio glass movement has to do with different colleges and universities having glass as part of their art department. And although traditionally glass has always been a very male-dominated kind of an endeavor, with the advent of the studio glass movement, at least 50% of the people who are in those courses are young women. Women well represented in the glass arts anymore. Well represented. So it looks like we've got lots and lots of little spikes on this piece. Those of you who are close by, you can kind of notice that the very end of that piece is redder than it is right there at that neckline that Rasmus is holding the torch on. And so there's a difference in temperature there. That view inside the furnace, that's special view that you only get to see with the Corning Museum of Glass. The fact that there's a camera mounted behind the furnace, that's what's happening there. It's not in the furnace, it's behind the furnace, which means that there's a hole in the back. Now that hole, to protect the camera, is covered by a very special piece of glass called fused silica. That fused silica is the silica sand melted all by itself. The temperature for that is close to 3,600 degrees. So Jen's got this one ready. You see that? A quick little tap after a little cooling chill with the shears. Heather going to take it over to the garage, and they'll load that in there with the others. All right, back to the green furnace. Collect some more glass. Making a gather. Making that gather with that green glass. You see that first gather? The pipe's not so hot. She got a nice amount of glass there, but the pipe's not so hot. But she'll make that next gather, and it'll be a bit larger, but there's a good chance that the pipe will certainly warm up with that second gather, and then she may use that pipe cooler. The team conferring there, Jen and George Kennard, talking about how they're going to move on, how different things are going to come into play, how they're going to put it together. So with that jack line now, Jen is creating that constriction in the glass. That means it's not likely she's going to gather over that. So she's going to make a small one of these. And back to the small paddles, back to the small cork paddles. Getting her tools ready, and she'll be able to proceed with this one, like the others. So in the history of glass making, almost 4,000 years old. The first 2,000 years, people only made pretty much these kinds of things, lots of solid things. Whenever they would make a vessel, they would make some kind of a mold. They would make a resist material that they knew that they could destroy after they had the piece completed. They would make the resist material perhaps on a piece of wire, something like that, and they would fill it up depending on how they wanted the interior of that piece to be. And then they would collect glass out of a furnace and coil it around that resist material. They knew how to make colors. Some of the oldest pieces in the collection have wonderful colored glass lines in them. And that meant that they were able to drape those lines around or make a thread with the glass. But then when the glass had been shaped, completed, and then cooled, they would go back in with a tool and be able to scrape out the interior part because it was made so that it would basically crumble after it was cooled. They would clear that out. The advent of glass blowing, that came about in the early Roman time, about 2,000 years ago. And one of the reasons that we generally refer to working with the material as glass blowing is because that advent of the bubble inside the material, that figuring that out, that collecting the material on the end of a hollow rod and being able to introduce air into it. It's so revolutionized working with glass that we just refer to it as glass blowing. Yep. It's still the number one revolutionary technique with the material. You know, even though with the advent of machines and probably 98% of the glass that's in our lives is done by machine, it's the whole idea that if you put the bubble inside, you can make all kinds of things happen really quickly, as opposed to having to do that casting process that I was talking about just a little earlier. So Jen, adding some more of those little spikes, those little sharp prunts. So there's a little bit of activity over there on the right-hand side. I see George has got some colorful glass bars connected to a solid rod. He's heating those up. He's heating them and shaping them. Heather heating up a blowpipe of some pretty substantial size. If you're paying real close attention, you may notice that different size irons and different size blowpipes have been employed to make the different parts so far. Well, when you're making a bigger piece of glass, you like to have a bigger pipe to work with. A lot of it has to do with the strength that you'll need to hold the weight, but along with that comes the ability or the torque that you need to turn it, and a bigger pipe makes it easier for your hand to turn that pipe. And so that's a big part of how you choose the kind of tool that you want. Yeah, George, heating up that colorful glass bar over there. Now, you probably didn't get to see it, but I saw George pick those up. There were two bars of glass, two round bars of glass, ingots, that were preheated in that garage. And George picked them both up side by side. Now he's melted them together. It looks like one now, but he's melted them together because they needed a good quantity of that colored glass. Because I think what they're going to work on with that is they're going to start to create that flower pot. Yep. And it's a dark gray color. All right, I see Jen working on that jack line, that constriction. Rasmus has the metal paddle. I'd say it's a good indication of getting ready to be able to detach this from that pipe. Rasmus will have it on that metal paddle, and they'll put that into the garage. By touching that neckline, that jack line, with a cold tool, setting up a nice little thermocline so that that tap allows it to break free.
I don't have a question, Bob, but an interesting fact, we have 400 people watching with us on both Facebook and YouTube.
We have 400 people watching on Facebook and YouTube. How about that? Yeah. Hey, thanks for that. We appreciate your company. We have maybe 50 of us here in the theater, so thanks for the support. We're liking it. All right, George has got a blowpipe. Heather's got that colorful glass that George was working on. George has probably got a little a little amount of glass there. He's cooling it, shaping it with that wooden scoop with our block. We'll get to see him put a breath of air into that pipe. There we go. And he's going to create a bubble. Now the bubble is most easily done by adding air into that pipe and letting the heat from the glass cause that air to expand. When that air expands, it creates pressure. That pressure pushes a nice little bubble up inside the molten material because that inside of that glass is still molten. Now Heather's going to heat up the glass color for George, and they're going to do what we refer to as a color drop. To be able to colorize this piece, George wants to get the color on nice and early. And so on that small bubble he's got, they'll place that concentrated glass color, and then he'll be able to shape it and stretch it over the outside of that bubble so that when they collect more material and they inflate that bubble further and further, that colorful glass will stretch right along with it. And of course, anyone who sees it after the fact, they'll think, wow, isn't that beautiful gray glass that they used? And they'll think that whole big flower pot was gray glass. But because you were here to see it, and folks in internet land, the same thing, they'll know that it's really a very small amount. Like if I were to tell you in ounces and pounds, he's probably got 6 ounces of glass. But if he makes 2 or 3 gathers, he's going to have 8 or 10 pounds of glass, okay? But that gray, because it's on the very inside, it's going to stretch with that bubble. And wherever the bubble goes, that's where that color will be. All right. Jen working on another. This is the final. Okay, this is the littlest one. No, it's not. Rasmus says, no, we're going to keep making these. There we go. All right, going to make another one. They're going to look great. How many have we got total? I lost count. 7, yeah. There we go. Okay. Yep, we're going to get, they may not all get on, she said. We're going to get 5 or 6 on there, but she's going to have an extra one just in case, you know. Murphy's Law. Yep, have an extra. Yep, so this one is a good example of why they use the cork paddles. That glass was really nice and hot. You could see it droop way down, and she squeezed it. You know, it doesn't have any marks on it, but it certainly changed the shape. Nice and smooth. So George was working diligently over there. Did you see that? He made that colorful glass into kind of a sombrero almost. They got it nice and hot because it was extended over the diameter of that bubble. And then he used that marver, the metal table over there, to squeeze that glass, come down all the way around the edge of that bubble. So he's got it on there really nice and uniform, but it's entirely covered. These metal marvers that we have made of that steel, it's a great heat sink for the glass. George's been marveling over there on the small one here for a while. But if you went over there, you could still sit down on that table if you wanted to. You know, it's nice and strong.
Yeah.
And draw the heat out of the glass, but it's still cool enough that it certainly wouldn't hurt you, wouldn't disturb you. Yeah, this glass process. See that, Jen, over there conferring with George? A few little details about, let's make it happen this way. And so that it's her vision to bring it all together. So getting a few more of these nice little spikes. A little bit of heat so that the glass has that good safe temperature. And then she has it brought over so that she can eyeball where she wants to put all those little spikes. We can see George using a very special tool there, a rake. George is raking the surface of the glass. Yes? What gas do we use for the flame? The furnace? The furnaces are heated with natural gas and forced air. But here, there is a propane flame there. Yep. And then, of course, it's assisted. The hot torch has oxygen assist, so it gets real hot. Yep. Yeah, why was George raking the glass? You know, oftentimes, for lots of different reasons, there could be little bubbles that appear on the surface of the glass. Sometimes it has to do with how the glass has been melting. Sometimes it has to do with how many different people were in there making gathers. And so to ensure that he gets a real nice, clean gather, he takes that metal rake. We call it a rake. It's a flat piece of steel connected to that long iron, and then you push it along the surface, and any of those little bubbles, it pushes them to the back because you like to gather from the front, and then you can put your blowpipe in there, collect that glass, and not have to worry about having extra bubbles. Yep. Sometimes they become a bit of a nuisance. Sometimes you have to go in there and dig them out. Digging a bubble out of the glass is a fun little exercise. Fun little exercise. Takes some good finesse, a well-experienced glass blower. Yep, you use a pair of tweezers and some cutting shears. Dig it out. Go in there and grab that little bubble and pull it out of there. Yeah, fun little exercise. All right. I see George. He's inflating that glass a little bit, so there's some glass blowing going on here. Yep. And those of us who are close, we can see that bubble increasing in size in George's gather. And he's being very observant as to how he sets up the glass. He's giving himself a reservoir of clear glass at the bottom. You see that? You can see the difference in that color. He's giving himself a reservoir so that he knows he'll be able to have enough material to create the size of a piece that he wants. Now he's cooling that off because he's going to go back into the furnace, collect some more glass. Looks like Jen's pretty close to having this last little fella ready to go here. There you go, a little tap, breaks it free from the pipe. Rasmus will take it over there to the garage and store it in there with the others. George got the rake. He's going to go through that process again. He wants to ensure he doesn't get any of them little bubbles in there. Yes? Yeah, when a little bit earlier we saw George with a whisk broom and he was sweeping on the glass. When you first pick up things out of the different parts, out of the garage, sometimes there's a little bit of debris in there. You know, there have been lots of different kinds of bricks, and there's bricks that make that thing, and there could be little different kinds of debris sitting in there on these ceramic shelves that are in there. And when you bring that glass out of there, whatever it is you've been storing in there, it might have just a little something undesirable on there. You take that corn broom, right? You don't want to use a plastic of any kind, right? You get good old corn broom, whisk broom. There you go. There's a gather of glass for you. Nicely done. George goes directly over to the pipe cooler. And with his foot, we don't get to see it, but he's a foot pedal operated. And it forces the water to come up into that trough, and it cools that pipe. You'll give it a wipe with a towel. And now with this wooden block. Yeah, that's a piece of wood, right? Soaked in water 24 hours a day. The wooden block allows George to shape that gather. He wants to cool that outside surface because he knows the inside is starting to get real hot, right? That new gather at 2,000 degrees going to cause that interior to start to heat up. But that's what he wants. He wants the interior now to get hot and malleable again so that he can inflate the glass. He can start changing the shape. He can move with that material. We saw him cooling it off over there at that bench. Remember, he was blowing the air on it to cool it off so that it would have the strength, it would have the integrity to be able to handle the weight and the temperature of that new gather. If he went in there with that interior bubble too hot, well, he may not have been able to come out of the furnace. It would lose its integrity, wouldn't have the strength. He'd want to pull it out of there and it would collapse. So you play one off against the other. You know, you make it cool so that you can have that support. And then you're looking forward to it heating up again, becoming malleable. So you can start doing the shaping, the different glass blowing process that you want to do. And he's also moving the glass. He's moving where that reservoir material is going to be by using the block. And now one of the most traditional of glass blowers tools is that newspaper, that soaked newspaper, wet newspaper. Glass blower knows that whenever you touch the glass, you're cooling it. And George, watching that bubble expand in there, he knows where he wants to cool the glass, because when glass is molten, it wants to behave like a liquid and move according to the path of least resistance. And so where that path of least resistance is going to be the hottest, right? And so if he wants it to blow up, if he wants that bubble to expand near the blowpipe, he won't touch that area. He'll touch the area that's furthest from the blowpipe and cool it so that it moves much more slowly than the area right near the blowpipe. Using the jacks, starting that constriction, that jack line, squeezing that constriction into the glass just off the end of the blowpipe, that'll be that break-off point. We need to have it. You know, glass is stronger than steel. Now, when glass fails, it fails catastrophically, but it's stronger than steel. And so if he didn't have that jack line in there, that neck line or score line, if he didn't have it there, it would be next to impossible to break. And when it broke, he'd have no control over where it would break. Having that neckline in there, just like that line in a Kit Kat bar, you know, you give it a little tweak and it's going to come break down that line. The same principle. So that neckline becomes real important. We'll get to see lots of inflation. Considering the size of that gather, we'll get to see lots of inflation taking place here. You see, so George now heating that upper portion, that upper neckline area, because he knows that as they go into the reheat furnace, the end farthest from the point goes inside the deepest. That's where that reheat furnace is the hottest. He's looking to balance out the heat to work in his benefit. Now, for those of you who are wondering about that camera, right? Look at the very tip of that bubble. You see that little dark spot? That's the window inside the very back of that furnace. That's what that little dark spot is. That's the window. Yep. Yep, that's the window. You can see it if you look straight in there. That's the window. Uh-huh. George is going to reiterate that jack line. He wants to make sure that he's got it well established. He knows how important it is. And then using that pair of jacks. And now, with Heather's help, she's going to be the inflation. George is going to have her blow into the blowpipe, start to increase the size of that bubble. So Jen drawing a picture, might as well use the floor, a little bit of chalk, makes it easy. She knows that if I draw a picture, the gaffer's going to have a good idea of what it is that we're looking for. Getting a good heat, back to the bench. Use a little bit of gravity. Let that slump down by letting gravity draw it away from the blowpipe. And now, with Heather's help, with that wet newspaper, starting to create the shape. for this flower pot, for that lower portion, for the base, for our cactus. A little bit of help here. The wooden paddle to protect George's arm. As the glass gets larger, I think I mentioned that early on, as the glass gets larger, there's more radiant heat. And that radiant heat can be uncomfortable. You know, when the ball of glass is 2,000 degrees. And so using that paddle to help protect him from that immediate radiant heat. And then they used it to quickly flatten the bottom. Put a nice little flat area. Creating this flower pot. Yeah, George, doing the heats, he wants to be real specific as to how and where he gets that temperature. Now, for us watching, we look in there and it's like it's all orange. How does he know when it's ready? The glass blower turns the pipe at the slowest rate he can, okay? And he looks for the motion of the glass. As the glass gets hotter, it's going to get weaker, right? It's going to get softer. It'll start to move. And the glass blower is watching for that movement. And then he knows, all right, he knows in his mind what the technique he wants to accomplish is. He knows, okay, that's hot enough. I can go to the bench and make it happen. A little gravity there. See that? Extend it. Get it to stretch out a little bit. Yeah, a little fire there. Make it look exciting. Get the wooden paddle. Catches fire. Yep. And turning the pipe with his left hand all the time, all of that time, turning the pipe with his left hand. Now, when you put a tool on that glass, it's like putting a brake on, but his left hand has to keep turning. And you have to keep turning at the correct pace. There's a correct amount of revolutions. It makes it look nonchalant when we're at the bench because we're rolling back and forth. But when the glass is hot, you need to turn a little bit faster. And as it gets cooler, it moves slower. And so you change that speed. And it's the experience that comes into play. Not only to have the strength to turn it and have the torque to turn it, but know the speed. You know, your left hand knows what your right hand needs, and it makes it happen. Whenever we're watching glass blowing, you know, our eyes are all on the glass. We're on the end of that pipe, right? But that left hand, that's the motor. That's what's making it happen. Real important part. So George's got a nice shape. Nice little flower pot started there. He's going to give it a look-see here. He's going to check it out. And now he's going to poke a hole in there. He's got a very special tungsten rod. He's going to get that tungsten rod really nice and hot. and then be able to poke it through the glass. See, Rasmus continues to turn, continues to rotate the pipe. George is getting it hot enough so that he can push that through. Engineering. He's engineering this piece. How is this going to work? What else is to come? Because he needs to know everything beforehand so he can engineer all the different steps. Why is he poking a hole in there? It's because they're probably going to cover over the top. And if they do that, it's going to be stuck in there, right? The air that's in there is going to be stuck. And if they heat it, and cool it, and heat it, and cool it, that air that's in there is going to go, right? It's going to expand and contract. And if the glass is hot, the air is going to push against the glass, and it's going to change the form. You know, he worked hard to get that form. He wants to keep it. Poke a little hole in the bottom so that if the air gets hot, it can come out. When the air cools down and gets sucked back in, no big deal. Keep the temperature safe enough so you don't change the form, and it'll be just fine. So just like a real flower pot, right? Got that hole in the bottom so that the water can drain out, right? So you don't drown your plant. It's a different function, but same hole. All right, George has got another blowpipe. Is this going to be the punty? Is that what we got coming? Is that the punty? Yeah, okay. Yep. So they like the position. They like the form that they've got. It's time to transfer that glass off of that blowpipe. And George is going to create a special punty. He's going to use a blowpipe to make the punty, the transfer iron. They want to trade it, they want to change it, but they need to still have a handle, right? This is going to be the second handle. And they're going to attach it to the bottom of the form. But George is going to create a very special secondary handle or punty so that he knows when it's time for it to release, all will go smoothly. Jen and Rasmus in a holding pattern, basically, keep the glass hot, but not so hot that it's going to change the form. Keep it hot so it doesn't want to crack and break. And George is creating what we refer to basically as a ring punty. Those of you who are mechanically inclined, you know that a tube is stronger than a solid rod. Okay, and basically George is creating a little tube. So this punty is going to be nice and strong, but he also knows that he'll be able to break it free later in the process, not have to worry about it. All right, here we go. George's going to attach that punty. He'll use that pair of jacks to help him. A pair of tweezers wouldn't be long enough, wouldn't be big enough. using the jacks, and he creates a little crease in the very end of that punty. That little crease will be handy come the end of the project here. But now he's going to wait. He wants that punty to create a little bit of integrity. As it cools, it's going to get stronger, right? The glass cools, gets stiffer, gets stronger. He's going to wait for it to be strong enough, and then he'll give them the okay. They'll cool that neckline, that jack line, and make sure that they've got it on center. It'll ride there nicely. And then a little bit of water. George using a very special Sophietta tool, a cone connected to the end of a metal tube. He was able to blow on that punty a little bit more, cooling it off. Jen cooling that neckline with water, making sure that it's the weakest point. There we go. A little tap breaks it free. Nicely done. How about we give them a hand? Yep. All you folks on the internet too, you can give them a hand. That was well done. They made it look real easy.
Question for you, Bob.
Okay.
Out of everyone that you've worked with in the glass world, who's been your favorite person to work with?
Out of everyone that I've worked with in my 40 plus years, who is my favorite person to work with? You know, I have a special fondness for my first instructor. His name is Bill Boysen. But, you know, George Kennard is probably my favorite person to work with. George is always, yep. George is always the top craftsman. He's always involved. He's always ready to make sure that the project is going to be just right. Yeah. You know, and even if we weren't here, and even if George wasn't here making that piece, I'd be saying George Kennard. He's just a top-notch guy. No doubt about it. I've had the opportunity to work with George in Seattle, Washington, and in Chicago, Illinois, and here at CMOG. Yep. George Kennard. Top notch. Ooh, nice. You can see the temperature difference there, huh? You can see the heat. George taking pains to straighten that up in a very special way. See, he's necked that down really narrow because he's going to tap it off. He's going to break it free. Going to break that little bit free. And he's not worried about it, right? Because he's got a hole in the bottom. He's got a hole in the bottom. So he's going to heat this up really good. Look at that. We got it. All right, they're going to add some detail now. Going to create some details for the flower pot. Yeah, flatten that top. George using the paper, cooling that side, while Jen helping to flatten that very top. There we go, a nice heat, and be able to create a nice crisp kind of an edge. Ooh, there's a big heat this time. So George, using the jacks, using that nice flat edge from those metal tools to create a nice crisp edge on that flower pot. That was the reason for all that heat. Is that the Craftsman here? Is that the size you made it? Right there. Okay. Nicely done. Different folks get started working with glass in a number of different ways. You know, there aren't really too many factory jobs available anymore here, especially in the United States. A few, not many. A number of different people can get their beginning working with the glass in a factory way, but most of us wind up beginning as art students in college. There's more than 40 colleges and universities in the United States that have glass programs in the art department. And you can get to learn about that material in that kind of a way. There used to be the Steuben factory right here in this very building. And a number of the gaffers on the Hot Glass Show team were gaffers for the Steuben Works. Yep, they got their start working in a factory. But most of us, colleges and universities these days, if you're working in an artistic environment, it's certainly a handy avenue to get started. Ah, here we go. Extra things going on. Now, very early on, I mentioned that Jen likes to use powders to be able to create the different effects that she wants, especially for the different fruits and vegetables that she does in her work. But she's got powders there for George, and that's what he's rolling in. He's rolling that hot gather into some glass powders, colored glass powder. That colored glass powder. Oh, you know, the flower pots, they usually have got that little extra ridge, right? That little extra rim, okay? I think George, that's what George has. He's going to make a rim. They're going to do a lip wrap, except it's going to be giant. It's going to be really big. It's going to be really big. George's getting another layer of that color. He wants it to be nice and rich looking. He'll use that other furnace now to melt that color in. Very cool. George has this very special shape. He wants to make that a very special shape so that he knows as he attaches it, he'll be able to pull it, but it'll come off in a nice, even stream. Yeah, he's got the color hot, nice and melted in. Now he's marvering it to create the good shape, but also the temperature. The temperature is going to be real important here as to how that is going to come off from that iron that he's got it collected on. Yep, marvering that glass into that kind of a double cone or a dreidel almost, if you know what a dreidel shape is. Here we go. All right, Rasmus is going to get that bit real hot. George is going to monitor the temperature, and he's going to be the one to be able to lay that on there. All right. See that? We need room to make this happen. Gonna need extra room. There we go. All right, watch close. Touch up and pulls. And he's able to establish that diameter. And it makes it around. And it draws it away nice and quickly. Very nicely done. Very nice. Yeah, heat that up real nice now to make sure it fuses. Make sure it sticks permanently to the rest of that flower pot. There we go, working together. Create that nice extra lip. George monitoring that shape and also that interior surface, what has become the very top of that flower pot. Very nice. Very nice. All right, now they can resume a little more normal positioning there at the bench. All right. The team working pretty well together here, making this happen. All right. Torching the punty, keeping it safe temperature. Can't forget any of those parts. The glass needs to be that 900 Fahrenheit. So this is one of those situations that you're taught maybe in your second year of glass blowing, and you're on a team and they're working with this big piece and they've been at it for a good while, and then somebody hands you the blowpipe and says, okay, keep this hot, and then they walk away. And then they walk away. There he is. He's back. You walk away. And, all right. Got to see what happened. The torch decided needed some kind of adjustment. All right. Lots of conferring going on here. We got Jen back in the seat. She's going to make sure that that lip wrap is nicely secured all the way around. A little extra heat, a little fire polishing, those kinds of things taking place. All right, I see George has collected a little bit of glass on the end of a small rod. Yeah, and Jen working on a little bit of detail there, watching how that lip wrap has come together. Oh, huh. Okay. Right. Okay. Very good point, George. Very good point. Now, yep. George brought it to my attention that the museum closes at 8 o'clock. But, of course, we want you to be able to see and watch all the goings on. So when it comes time to leave, you'll have to go out one of the side doors, okay? I think we'll be able to give you a little better instruction toward the end of the demonstration. But, yep, you won't be able to go back into the museum. You'll have to come down and go out one of the side doors, okay? Yep. We don't want anybody to get in trouble with security. All right. The team working on keeping that flower pot nice and crisp. So George has gotten the big lobe, all right, the big part of the cactus. So they're getting ready to start to build the cactus here in the flower pot. They got the flower pot set up. Now it becomes real important to get a good safe heat. It's going to take a few moments when they get it ready. And so George gives it a quick little brush just in case, looking to make sure there's no debris caught in there. And then he'll look to heat that very tip. That's the area that they're going to want to connect. That's the area that's going to come out of the soil there in the flower pot. So Jen's getting prepared. George, he's got this first lobe set up. He's got a nice amount of heat involved. They're going to make this connection. They're going to bring it together. Going to be able to So it's going to be a matter of matching the heat, right? Having that first piece of the cactus. Jen's going to be extremely instrumental, being able to locate, place that. Heating the tools a little bit, because you don't want to touch the glass with anything cold. Want to heat those tools a few hundred degrees for sure. 400-500 degrees, because the glass is going to be considerably hotter. They're watching that punty, making sure that it stays at safe temperature. All right. A little extra detail to take care of. There's not enough movement. And so they need to poke another hole in there. Remember, they poked that hole in there to start with? Well, apparently it's gotten closed up. And they're going to poke another hole in there to relieve the air a little bit, so they can get that glass to respond the way they need it to. Using a torch, heating that tungsten rod, and then pushing a small hole into the bottom. Yep, establish that good overall heat into the furnace. A good soaking flash. And now bring that heat back into that top side. Yeah, so some critical moments here. Here we go, that placement. Yep, placement with the tools, a quick little tap. There it is. There's that first lobe. We get to see it. Yeah, sure. Give him a hand. That was critical. Nicely done. George not wasting any time. He's going in to get the next one. Those torches. Look at Heather. Got a torch in each hand. She's all right, George is creating another punty. He's going to go collect. Thank you. Yep. He's going to go collect another one of these. One of these beautiful cactus parts. So as Jen gets this part prepared, George is going to collect that next little part. Yeah, very nice. Rasmus working diligently, doing the heats. Temperature, timing, and teamwork. Yep, the 3 T's, all very important. All coming together here right now.
I want you to just heat this here for a sec. I just come into the glory hole. So be careful, okay?
Okay.
Nice and easy. Flash the whole thing, Bob?
Yep. So yours truly gets involved in the process here. This pair of idle hands. George says, all right, get to work. Okay.
I would say just take a. I'll give you like.
Yep. Yep.
I got this. You just heat this right there. You got her, buddy?
Got her. All right. Preparing these. Yeah. Thank you for that, George. It was on my mind. I know. I'm ready for a haircut anyway, I think.
Yeah, go ahead. I'll flash.
When you go, you want me to go to the glory hole? Okay. All right. All right, so preparing the part in the garage, that's what I'm looking at. That's where my attention is here. As they get ready to attach that next component.
Yes?
I'm hooked.
Yeah, we got it.
Okay. Same old, same old.
Same old, same old.
Okay. Very nice. All right. As they work to detail what they've got in the flower pot, George preparing to secure another so that the cactus can grow. Got it. All right, so the sequence continues as we involve these other parts, these other little details. They've been sitting in the garage, but they need to be heated to a very nice, compatible temperature so that they can be attached, well secured And George, of course, has this in hand. Got the sequence. We just repeat it. Looks pretty successful. All right. George creates the next punty, pick up another. And as they get added on, constructed nicely, you ready? Working the sequence. Making those adjustments, adding those details. Nicely done. Big time teamwork. Now there's a significant little addition that none of you have seen because Jen created some little glass flowers to go on the cactus beforehand. And so these lobes get attached, but then there's also these little glass flowers. All important heats. You're good to go. Last one, huh?
Yep.
Okay.
No, there's one more.
Okay. All right. I'm still here, folks. I'm just focusing my attention in a different way here. Yeah, you can see them attaching another one. They got nicely done. They got that system worked out very nice.
You want to take these forks?
Yeah.
Take the shovel, heat the shovel up first, and slide those petals.
All at once?
Yep.
Yeah. All right. Our cactus is growing. Looking good. Yeah, there we go. Looking good. Okay. Am I been laid off? No, 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 not. Yep. Lots going on. I just have to take a minor role. That's what's going on here. I just take a minor role. I think George has got that few final touches there. Rasmus got it under control here, making all those heats.
Remember, we're going to wrap up the stream before we give away the glass at the end, so don't go right into it.
Being very careful with the heats. George has 4 flowers. 4 flowers. He's going to keep them heated, special temperature, so that they're easily attached. The first one, and Jen will heat it. You want a second door there? All right, there's that first little flower attached. Cactus flower. All right. Looks like nods. Okay, he's going to flash. All right, timing, bringing them together. Flower number 2, George, back to the garage. That's good, safe temperature. That nice little nest they've been hanging out in. All right. Looking good. Small details, making the adjustments. All right. There's the nod. They're ready for the next one. George delivering those nice little heated flowers. Jen will pick that spot, place it down there. Paddle full of posies, indeed. but they're cactus flowers. Wasn't there a movie? I think Goldie Hawn played in a movie called Cactus Flower.
You want that last one, Jen?
Gonna go with 3. Okay. 3 nicely placed little flowers. Now, those flowers look kind of brown, don't they? They look kind of muted. Tomorrow, they're going to be bright red. They're bright red flowers. They're bright red flowers. Now, the cooling process for this is going to be very, very tricky because of all that thick glass. Each of those lobes, each of those parts are solid, and so they're thick. They take a lot of cooling time. I wouldn't be surprised if they don't give it 16-hour cooling time. Yes. How much does it weigh? Looks like it weighs 2.5 cactus. I don't know how much it weighs. We know we're going to have to inquire with Rasmus or Jen. Looks like Jen's got a good hold of it. You know, and she's the brave one there going up against that furnace with those short pants on. It's hot up there. Radiant heat coming out of that furnace as well. There we go. Nicely done. Rasmus with the fireman suit, protective gloves. Yep, Kevlar gloves. He's got the hood on as well. They'll make sure the punty's hot enough so that they can break it free. And then this piece is going to go into the cooling oven. It'll probably sit for 16 hours. I wouldn't be surprised. I wouldn't be surprised. They're going to give it extra cooling time because it's got so many thick parts, and a bunch of those thick parts are connected to each other. Yep. Jen Violette, nicely done. Very special piece. Tomorrow, as those pieces all cool, get down to room temperature, then we'll get to see those true colors. We'll get to see that vibrant green. We'll get to see that really nice dark gray color for the flower pot. And those little flowers, they're going to be bright red. Bright red. Yeah, you're noticing that they're being very careful as to how they set that down. Don't want any extra bumps or thumps as they put it on the yoke or they put it on that bench. We're going to do several of those flash heats. Look to get a nice uniform overall temperature. The bottom part, most concerned, right? The top areas go deep into the furnace. They get plenty of heat. But that bottom part, it's at the very opening of that door. That temperature, although it looks all orange in there, temperature at that door is probably 500 degrees difference than 6 to 8 inches inside. It's a big difference. Extra heat from the torch for that bottom, for that punty. Make sure the glass isn't too cold. Here we go. Last flash, George said. Last flash. All right, George has the piece. He's got the punty. Jen has a pair of shears, straight shears. Rasmus in the fire uniform. Back to the bench. Another good heat at the bottom. We can see those glowing colors at the very tips of those cactus. George is going to chill that punty. The tap breaks it free. Very nicely done. Into the cooling oven, into that annealing oven. You get a chance to sit there. Ladies and gentlemen, Miss Jen Violette. Miss Jen Violette. Yeah, nicely done. Nicely done. George Kennard. Rasmus. Heather, Frederick, all in the team.